Hi, hello, namaste. Welcome to all my viewers. So today we are going to understand what is deterministic finite automata, and let's see about what are the contents of information which you're going to learn today in this presentation. So we are going to check about what is DFA and introduction to DFA, construction and analyzing DFAs, implementation of DFA in software and hardware, advancements and future trends of DFA. So coming to section 1, introduction to DFA. So let's learn more in detail about what is DFA. So deterministic finite automaton, it is defined as a model which is used to recognize patterns within input strings commonly implemented in hardware and software for various problem solving tasks. It is actually a mathematical model which is capable of recognizing within the input strings commonly implemented in the hardware and software for various problem solving tasks. So the key characteristics of DFA are: it is finite number of states and transitions in it between these states based on the input symbols, making it as a deterministic in nature. So, and coming on to applications of DFA, so they are utilized in lexical analysis, parsing and pattern recognition in fields such as computer science and linguistics. So these pattern analyzing is used, or pattern recognition is used in linguistics like Google Translate or etc. And lexical analysis is a concept in which they take a huge number of data set and train on it, and which is deterministic in nature. So elements of DFA or deterministic finite automaton. So state set, a DFA consists of a finite set of states, each representing a unique configuration of the system. So it's actually, state set is nothing but it is a finite set of states which representing the unique configuration. Each state has a unique configuration in the DFA. So alphabet, the input alphabet is a finite set of symbols that the DFA uses to transition between states. So it is actually, alphabets is a finite set of symbols which is used in the DFA, which uses to transition between the two states. So transition function is also another uh, category which is being used in the DFA. This function defines the state of transitions based on the current state. It and input symbol determining the next state. So it is actually nothing but it defines the state transition based on the current state, on which state it has been kept, and the input symbol determining the next state. So coming on to accepting states. Certain states are designated as accepting states, indicating that the DFA has recognized a valid pattern. So coming on to deterministic versus non-deterministic automaton. So deterministic automaton, in a DFA, for each state and input symbol there is exactly one transition to next state, making the computation unique and predictable. It's actually predictable in a manner so that we can say that there are how many number of states or in each operations taking place, which is in input symbols and also been recorded or been known for the user in the case of deterministic automaton. In non-deterministic automaton, contrasting DFAs, non-deterministic automata may have multiple transitions for a given state and input symbol, leading to ambiguity in computation. What happens is, in DFA there are fixed number of transitions and states occurred. In non-deterministic automaton, there is no fixed number of states or input symbols, which leads to ambiguity in computation. So applications of deterministic finite automaton. So there are applications in which the DFA is being used are lexical analysis. DFA are widely used in compilers and interpreters to recognize keywords, identifiers and tokens in the programming language. So it's actually the DFA, right? So in DFA what happens, there are number of states which are being known, or it is been defined, which is determined, right? It is determined before itself. So in lexical analysis, there are there are compilers, right? In compilers, they use this like DFA concept, because to recognize keywords, identifiers, and other tokens in the programming language, which is already, which is constant and which doesn't vary, and it is predefined, right? So pattern matching, there are employed in text processing and pattern searching algorithms to identify the specific patterns within the string. So it searches the, in a text there are there are algorithms which have been used to identify the same patterns. So like search indexing, Google indexes the websites, right? So there it uses pattern matching. So and then language recognition. Coming on to the other application of DFA, language recognition plays a crucial role in formal language theory, aiding the recognition of regular language and grammars. So like for example, Grammarly is a platform where it recognizes the language and which corrects the grammar. So this in this state we use deterministic finite automata so that to give the appropriate results. Coming to section 2, constructing and analyzing DFAs. So designing a deterministic automaton, like it has a state diagram, transition diagram, and an example. So coming on to state diagram, the visual representation of DFA showcasing states, transition, and input alphabet, providing a clear depiction of its behavior. Actually, state diagram states that it is a visual representation of the DFA showcasing states, transitions, and the input alphabets, providing a clear depiction of its behavior. Transition table, the tabular format illustrating the state transitions for each input symbol, aiding in the systematic construction of a DFA. So coming to example of deterministic finite automaton, walk through the step-by-step construction of a simple DFA to recognize a specific pattern of oral language. So coming to deterministic finite automaton operations, string acceptance, explaining the process by which DFA determines whether an input string is accepted or rejected based on its transitions and final state. So what is string acceptance means? It actually processes the which is explaining the process by which it determines, DFA determines whether the input signal is complete accepted or rejected based on its transition and final state. So coming to language recognition, discussing how DFAs are utilized to recognize and classify strings belonging to a particular formal language. So deterministic property, emphasizing the deterministic nature of DFA and its significance in ensuring unambiguous computation. So limitations and complexities of DFAs. Comprehensive power, highlighting the types of language that can be recognized by DFA such as regular languages, and the inherent limitations in recognizing more complex languages. There may be a problem which occurs while using the DFA, which is it is difficult to analyze complex languages with the help of DFA. So next limitation is state explosion, addressing the challenge of scalability. As the number of states and transitions in a DFA increases, the implicating its practical applicability. What happens is when the DFA is being reaching a certain limit of its states and transitions, there is an scalability issue where the number of states and transitions are fixed. When the user of a platform changes or it increases the pressure of the states or transitions, there is a risk, or it is incapable of which is incapable of scaling those models which are being based on the DFA architecture. So comparison with the other models, contrasting DFAs with non-deterministic finite automaton and another computational modes in terms of expressive power and computational complexity. So automizing deterministic finite automata. So it actually minimization is a concept where exploring techniques to minimize the number of states in DFA without altering its language recognition capabilities and enhancing the efficiencies. So in this process of minimization, we actually explore some techniques into which there are the number of states can be reduced in a DFA without changing or altering the language recognition capabilities and enhancing efficiencies. So deterministic operations, strategies for optimizing and transition functions and state transitions to streamline the DFA's computational process. It actually strategizes the optimizing for optimizing the transition of functions and states to streamline the DFA's computational process. Actually, it reduces the load on DFA. Real world examples showcasing practical scenarios where optimized DFAs are employed for efficient pattern recognition and language processing. Actually, these have been efficiently reduced, right? Or if it is changed and it has been checked that the DFA is being efficiently used with the real world or not.